Lesson 9, working with prime numbers. First off, what is a prime number? A prime number is just a counting number greater than 1 and has exactly 2 factors. And remember, factors are always the numbers that you multiply together. And these factors of prime numbers are always 1 and itself. So if you look in the picture, everything shaded in yellow are all prime numbers. You can't break them any further than itself and 1. Composite numbers are counting numbers with more than 2 factors. And you use prime factorization to break down the composite numbers. And you would write them as a product of prime numbers. So if you look in the picture here, you can see there are a lot more composite numbers than prime numbers. In an example, if we take a look at 4, the factors of 4 would be 2, 1, and 4. Those would be they would have 3 factors to get the number 4. Let's take a look at some examples here. We want to prime factorize 36 using a factor tree. So I'll first start off with writing 36 down, and we need to use a prime factoring tree. So we want to factor this. So I know that 36 can be broken down as 4 and 9. And I know that 4 can be broken down as 2 times 2, and 9 can be broken down as 3 times 3. And so if I were to put my answer together, we would say it would be 2 squared times 3 squared, or you can write it as 2 times 2 times 3 times 3. Another method of prime factorizing is using division by primes. You're just dividing by a prime number. So if I start off with 45, and we're going to draw our box, the division sign is going to be upside down. We're going to divide by a prime number. So I'm going to take 5. 45 divided by 5 is 9. And then I can divide this 9 by a prime number, which would be 3. 9 divided by 3 is 3. And I can divide this down by the 3 outs. 3 divided by 3 is 1. And you want to make sure that you get all the way down to 1 on the bottom. And so my prime number, or prime factorized numbers would be the ones on the side here. So I can rewrite it as 3 squared times 5, or I can write it as 3 times 3 times 5. Let's look at some other examples. Prime factorize 25. This one, we'll do the factor tree. So I'll break this down. This would be 5 times 5. I cannot break 5 down any further. You don't have to break this down and say, well, this is 5 times 1. So you don't need to do that. So you just keep it until you get all prime numbers in the end. And so my answer would be either 5 squared, or you can write it as 5 times 5. Prime factorize 100. This time I'll use the division by prime factorized by division. So I put 100 in here. I can take a prime number out, so take a 5 out. 100 divided by 5 would give me 20. Prime factorize that again. I can divide a 5 out and I get 4. Prime factorize that again. 2, divide a 2 out and I get 2. I can prime factorize that one more time, divided by 2 and get 1. And so my answer would be 2 squared times 5 squared, or 2 times 2 times 5 times 5. And then prime factorize 16. Again, I'll do division by primes. I can divide this by 2. 16 divided by 2 is 8. Divide by a prime again, divide by 2. So half of 8 is 4. Divide by prime number 2, you get 2. Prime factorize that by 2, you get 1. So the answer for this one would be 2 to the 4th power. And the last one, divisibility test. You can use this to determine whether numbers are prime or composite. And so you can see in this table, the condition here, the number is even with it, if it ends in with 0, 2, 4, 6, or 8. And if it's divisible, and that means it's divisible by 2, so 2 is always a prime number. So if it ends a number, an even number, you know a prime factor would be 2. The sum of the digits is divisible by 3, then it's divisible by 3. So 3 is also a prime number, so that's another way you can determine if 3 is a prime factor. And the same thing with 5. The number ends in 0 or 5. So we want to determine whether the following numbers are prime or composites and state how you know. So here we have 1,237,526. We want to determine, is that prime or is that composite? So I know that it ends in a 6. And I know that 6 is an even number. So I know that it is divisible by 2. And if it's divisible by 2, it can have more, it's going to have more than 2 factors. Because remember, prime numbers have exactly two factors, itself and 1. And so if it's divisible by a number bigger than 1, then it's not prime. So this is composites because it's divisible. It's divisible by 2. And we can check to see if it's divisible by 3, because if we add up all the digits, if that's divisible by 3, then that would also be divisible by 3. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 7 is 13, 13 plus 5 is 18, plus 2 is 20, plus 6 is 26. 26 is not divisible by 3, but it is divisible by 2, but it's still a composite. 520,611, is that a composite or prime number? So we can look at it, it ends in 1, so we know it's not even. But what if we add up all the digits? 5 plus 2 plus 0 plus 6 plus 11, 1 plus 1 gives me 15. 15 is divisible by 2, or divisible by 3. Therefore, it's going to have more than 2 factors. So this is composites. And the reason it's divisible by 3. Again, if it's divisible by a number greater than 1, then it's composite. If it's divisible by 1 and itself, then it would be prime.